we can have those forces. No, like forces will be there, but they will be weak. But still forces will be there, right?
Okay, sir.
So where we can have multiple layer in case of physical adsorption, we can have multi-layer. So formation of multi-layer of adsorb particle. While in case of chemical, monolayer formation will be there. So four differences. Okay. So what are the differences? Can you tell me again? Now first one. Which type of forces are present between physical adsorption? Van der Waals forces. Which in chemical forces means chemical bond will be there. Which one is stronger? Chemical adsorption is stronger. Which one is weaker? Physical adsorption. Which is reversible? Physical. Which is irreversible? Chemical. Where multilayer forms in physical adsorption. Where monolayer forms in chemical adsorption. Clear this thing? One more difference is that here activation energy is low. And here it is more high activation. Now, how it is decided that I will explain later when we'll discuss in this thing in detail. Okay. Just for the difference purpose, you remember this five. Okay. This is what about the surface chemistry. This is what only you have in surface chemistry for IP. Okay. There will be some 2 mark question like what is absorption, give example, adsorption, give absorption, give example, what is that sorption, desorption, like that only. And the difference between physical adsorption and chemical adsorption. This is what the differences you have. Now next we have colloids. Now generally any mixture we classified into three types based on the size of particle. One is called as true solution, another one is called as colloids, and the another one is suspension. In true solution, the size of particles of this true solution, it is less than 1 nanometer. If any mixture is there in which size of particle is less than 1 nanometer, then those are called as true solution. If any mixture is there in which size of particle is between 1 nanometer to 1000 nanometer, those are called as colloids. Okay. And if any mixture is there in which particle size is more than 1000 nanometer, those are called as suspensions. Okay. Now in true solution, they are homogeneous in nature. Let's suppose if we are taking water and if you are adding salt in that, that will form a homogeneous. That is example of true solution. Okay. Then comes colloids. Colloids are there, they will be heterogeneous. Okay, and suspension will also be a heterogeneous. Now, what is the definition of colloid? A colloid is a heterogeneous system in which one substance is dispersed, which is called a dispersed phase, as a very fine particle in another substance called a dispersion medium. It's if you compare with the solution, what we are doing in solution, solute particle enters into the solvent. Here, dispersed phase is entering into the another one that which is called a dispersion medium. Dispersed phase and dispersion medium will be there. Dispersed phase will enter into the dispersion medium that is called as colloid, and it is heterogeneous in nature. Okay. So what is the colloid? It is a heterogeneous system in which one substance is dispersed, which is called a dispersed phase, as a fine particle in another substance called a dispersion medium. Okay. So let's suppose if you have the colloidal solution of copper in water, then copper is dispersed phase while water is dispersion medium. Do you understand this basic thing about colloids?
Yes, sir.
This is what if we compare we can compare this with this solution. Like dispersed phase is like solute, while dispersion medium is like solvent if we compare with the solution chapter. Okay. And colloids are also called as colloidal solution, or they are also called as sol. Okay. Now main thing in colloid that we have classification. Different classifications are there based on some properties. Now first one, classification based on the physical state of dispersion, dispersed phase and dispersion medium. Now look at here. If dispersed phase is solid, and dispersion medium is also solid, then that type of colloid is called a solid sol. Okay. But in solid sol, dispersed phase as well as dispersion medium will be solid. When comes normal sol, in that case, dispersed phase will be a solid, while the dispersion medium will be liquid. Paints, cell fluids are the example. Okay. Then aerosol. Now aerosol, in aerosol, what happens? Dispersion medium will be a gas, while the dispersed phase will be a solid. Smoke. Perfect example. You have this for IP. They are given like what are the dispersed phase and dispersion medium in smoke, milk, and fog. This is the question for 2 marks. So aerosol, smoke is the example. In aerosol, what is the dispersed phase? Solid. What is the dispersion medium? Gas. Okay. Then gel. Dispersed phase will be liquid. Dispersion medium will be solid. That is gel. Now you see milk. In milk, dispersed phase as well as dispersion medium both are liquid. Okay. Now here, one thing is missing. Which one thing is missing here in all those combination? If you see here, solid, 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 liquid gas, liquid, liquid, liquid,
Gas,
solid,
sir.
liquid
Gas,
gas.
gas.
Why it is missing? What do you think? Why it is missing?
Because both of
Are
them
you
have
able
the
to hear
same
me?
attractive forces, right? Less than that of van der Waals.
What?
Like both of them are like distant. The molecules of gases are distant from each other, so they won't have enough interactive forces. Maybe.
Okay. Any other reason? Means gas plus gas system we do not consider as colloid. Why? What is the reason? This is what the colloids we consider, these systems. Gas plus gas we do not consider colloid. What is
Gas
the
plus
reason?
gas will always be homogeneous, never
Ah,
gaseous.
yes. You see here, what is the basic difference here between the, for the colloids we are written? True solution is homogeneous, while colloids are heterogeneous. Even in the definition, what we say, it is heterogeneous system. If we add gas to another gas, they will form homogeneous system. Okay, so it cannot be a colloid. So gas plus gas cannot be a colloid. Understand this one? Now another classification. First here we classify based on the physical state of dispersed phase and dispersion medium. Now we classify depend on the type of particle in dispersed phase. Okay. Now simple thing. Now what is multimolecular colloid and macromolecule? Now what is the colloidal particle size? You tell me first.
Colloidal from 1 nanometer to 1000 nanometer.
1 nanometer to 1000 nanometer. Now let's suppose if some one particle is there. I have one particle whose size is zero point 0.1 nanometer. Can I consider it as colloid? It is zero point 0.1 nanometer.
No, sir.
No, sir.
But if I take, no, right? But if I take, let's suppose that zero point 0.1 nanometer particle is there. Same 10 or let's suppose 20 molecule I have taken, and all they combine together. Let's suppose they aggregate and they form again one more molecule. So what will the size of that particle or that molecule? See, I am saying initially I have one particle whose size is zero point 0.1 nanometer. Is it form that particle will form colloid solution? If I put that particle in the dispersion medium, will it form colloidal solution?
No, sir.
No, sir.
It will not form, right? Why? Because particle size is what? 0.1 nanometer. And we know in colloidal solution, size of particle is between 1 nanometer to 1000 nanometer. Okay. So zero point 0.1 it is not forming. Let's suppose that zero point 0.1 nanometer one particle is there. If I take same 20 molecules like that, 20 particle like that, and all they combine together and they form one another particle. Now what will the size of that particle if I take total 20 particles like that? What will the size then?
2 nanometer.
2 nanometer. So if that dissolve in dispersion medium, can I say it is colloid?
Yes, sir.
Are you understand what I am saying? I have one particle whose size is 0.1 nanometer, and same 20 particles I have taken, and all they combine together, they get stick with each other, and they form one molecule. What will the size? 2 nanometer, right? So now this 2 nanometer particle, when I dissolve in the dispersion medium, can I say that solution or that mixture is colloid?
Yes, sir.
Can I say that as the colloid?
Yes, sir.
Yes, sir.
So that is called as multimolecular colloid. Look at here now. What is the definition of multimolecular colloid? Single particle size is not in the colloidal range, but these molecules may aggregate, means combine together to form a particle in colloid range. Like that initially zero point 0.1 nanometer particle we have taken. It is not in the colloidal range, this 1 to 1000. So I cannot consider that mixture as the colloidal solution. But if I take 20 or let's have a 10 also, then the size will become 1 nanometer or 2 nanometer. And if I dissolve that particle in a dispersion medium, then I can say it is colloidal solution. Such type of solutions are called as multimolecular colloid. We need many molecules to form colloidal solution. That's why multimolecular. Clear this thing? Then next one is macromolecular colloid. Macromolecular means what? Whatever particle you are taking initially, that particle itself has the size range between the colloidal. That is what between 1 to 1000. Single particle itself has size in colloidal range. Understand this?
Yes, sir.
Clear this two? Okay. Now these two for IP they do not have anything. Now one more thing. Now listen. Let's suppose you had taken one bucket. Let's suppose water you had taken, and in that you have added some sugar initially. Will that sugar completely dissolve in that water?
No.
Let's suppose initially we add some 100 gram of sugar. That will dissolve, or we can take salt also. We have added some 100 gram of salt. Will it dissolve completely in that water?
Yes,
Yes.
sir.
Yes. If you take now, next time we will take some 500 gram. If I add in that water, means another beaker, let's suppose, bucket you take, in that we have added. Will it dissolve completely?
No, sir.
It will not dissolve, huh?
It will depend on the saturation of that solution. Of that.
No, no, no. We are saying one bucket, right? 15, 20 liter bucket we are saying.
Then it will
It
dissolve.
will
It
dissolve.
does, sir.
It will dissolve completely, right?
Yes,
Yes.
sir.
Yes, sir.
Now take another condition. You have taken the bucket, okay? Some detergent powder you take. Let's suppose initially we take very small quantity. We add in that bucket. Will it form that foam or something like that initially with small
If it
amount
is
of that,
very small, then it won't form.
right? It will not form. Means can I say when I am taking very small amount, it is not forming any foam and all. But if I take more amount of that detergent, what will happen? Foam will
It will
form, right?
form.
So when we are taking some small concentration at low concentration, can I say it is behaving like a strong electrolyte? Because when I am taking salt, that is NaCl, it is strong electrolyte, right? So it is dissolving, whether we are taking small amount or higher amount, low concentration or high concentration, it is dissolving in that water. But when I am taking detergent, when I am taking low concentration, it is dissolving in that. Not that foam and all, nothing is forming. But when I am taking high concentration of it, at that time it is forming foam. Such type of colloidal solution, they are called as micelles or micelles, anything you can pronounce. Okay. So at low concentration, they will behave like a strong electrolyte. They will completely dissolve. But when we are taking high concentration, they are forming colloidal solution. Like two heterogeneous solutions, like heterogeneous system is forming, right? When we are adding high amount of detergent to the water, we are getting two different thing, right? It is not a one thing. We have water also, that foam type of thing also. Understand? Clear this thing.
Yes,
What is micelles or
Yes,
micelles?
sir.
At low, it is the type of colloid in which at low concentration that particle behaves as the strong electrolyte, but at high concentration they will behave as the collide, or they will form a colloidal solution. Clear this thing? This is what we have. Okay. Now, what is the micelles? There are some substances which at low concentration behave as the normal strong electrolyte, but at high concentration exhibit colloidal behavior due to formation of aggregates. The aggregates particle form are called as micelles or micelles. These are also known as associate colloid. Means what? Micelles or micelles, they are also called as associate colloids. Clear this thing? What is micelles or micelle? Substances which at low concentration behave as the strong electrolyte, but at high concentration forms colloids. Those are called as micelles. Clear?
Yes, sir.
Clear this thing?
Yes, sir.
Okay. Now, this micelle formation or micelle formation takes place above certain temperature. That temperature is called as Kraft temperature. Here, this for 2 marks. Huh? What is definition of Kraft temperature? The formation of micelles or micelles takes place only above particular temperature, which is called as Kraft temperature. Okay, and above one particular concentration also. That concentration is called as critical micelle concentration (CMC). Formation of colloid takes place only above certain concentration. See here, that's what the definition. At low concentration, it will behave as a strong electrolyte, but at high concentration, it behaves as the colloid. So, at from which concentration it start behaving as the colloid? That concentration is called as critical micelles concentration. Clear this thing? Okay.
Yes, sir.
And on yes, and on dilution, these colloids revert back to the individual ions. Soaps and detergents are the example. Not required this thing, but we know that soaps they have some lyophobic and lyophilic part. Okay, now what is this thing? We'll see. Now this is one more question, the most important from this chapter for 4 marks. Mechanism of micelle formation or micelle formation. Okay. Now we have soap. Soap we know they are the salt of fatty acid. They are the sodium or potassium salt of higher fatty acids. And how we represent as they are the salts of acids, carboxylic acid. So RC double bond ONA. Salts of sodium salts or potassium salts of carboxylic acid. Now this is what the sodium stearate, soap formula. Now how many carbon atoms are there? How many carbon atoms are there? 18 are there, right?
18.
Now C double bond ONA. Between this oxygen and between this sodium, which bond is there? Ionic bond. So it will dissociate to give this part negative ion and sodium as the cation. Now if I take only this part, I am talking about only this part, and now this is not of any use. We'll only talk about this part now. Okay. So now when I am taking this part, look at it. Here I have written. Now we know carbon, they are the hydrophobic tail. Hydrophobic means what? They are not water loving. Phobic, hydrophobic, not a water loving. Do you remember when we study the physical property in all organic chapter? We used to say that lower members are soluble in water while the higher members are not. Because as in higher member, number of carbon and hydrogen increases. As the number of carbon hydrogen increases, that molecular mass increases and they become less soluble. Same thing. Now you see here, total how many carbon atoms are there? How many are there here?
17.
17, 18. So we can say they are higher member. Okay. And the higher member are not water soluble. So we can say that hydrophobic. So this part from here to here, it is called as hydrophobic tail. Okay. And now here C double bond O minus. Now here it is like ionic part. It is polar also. So this is what water loving. So we call it as hydrophilic head. This is called as hydrophilic head. Which one? C double bond O minus is called as hydrophilic head, while the carbon chain, hydrocarbon, that is called as hydrophobic tail. Clear till this point?
Yes, sir.
So I can write down like this. So when you have a question, you will write down first thing that soap is sodium or potassium salts of higher fatty acid. We'll write down this formula dissociation, and you will talk only about this part now. So we can write down this as from here to here it is hydrophobic tail, and this is called as hydrophilic head. Clear? Now this hydrophilic head is also called as polar. That's what I said initially. This is polar part, so it is also called as polar ionic head, while the hydrophobic tail is called as non-polar. Okay. Now negative ion means what? What I said, we'll talk only about this part. So negative ion, that is RC double bond O minus, is many molecules, they will aggregate to form a micelles of colloidal sign. Means many molecule will combine, and when they combine at that time, their particle size will become between colloidal range. So they will form the colloids. Okay. Now you tell me from this part, which one is soluble in water?
Hydrophilic.
Which one is soluble in water?
The polar
Hydro.
part.
Hydrophilic is soluble and hydrophobic is insoluble. Okay, now look at it. So when I am taking water in beaker and when I am adding that soap, which part will which move towards first?
Hydrophilic.
Hydrophilic.
Hydrophilic will move, right? So after some time, they will arrange themselves like this. Now this circle is there, right? Circle represent the surface of water. Okay, it represents the surface of water. So which part from the soap or from here will move towards surface?
Hydrophilic.
Hydrophilic. See. So after some time, they will arrange themselves like this. Okay, that long hydrophobic tail, which is insoluble in water, is directed toward the center, while the soluble polar head is on the surface in contact with water. Like when we add this soap molecule to the water, around one water molecule, they will arrange themselves like this. That hydrophilic part moves toward the center, while the hydrophobic move toward the center, while the hydrophilic try to move toward the surface of water. Okay, clear this thing?
Yes, sir.
Yes, sir.
And that micelle, this is called as micelle formation. Okay, and it contain up to 100 carboxylate ions. Okay. Now, in case of detergent, sodium lauryl sulfate, this is the formula. Now, what is the polar group here? This is SO4 minus because sodium, no use. See, like this. Here we take soap. Sodium will remove, no use. Only this part will be used. Okay. Here also same thing. Only thing is that formula is different. Again, when it will dissociate, SO4 minus you will get. So this SO4 minus is polar group, while this carbon chain is what? Hydrophobic. Clear this thing? So when you will get question, how will write down? These structures are very important. Okay, and from this structure, which is hydrophilic part, which is hydrophobic part, that you have to show. Clear this thing? Can you write down this question now? This is the most important question from this part for 4 marks. Can you write down? This is what the first thing that you have to write down. First thing that you will write down that what is the formula of sol or how it is made. Second, we will talk about the structure, like what is meant by hydrophobic tail, what is hydrophilic, why we call that, because this part is hydro, this part is water loving. Sorry, it is not like this part is water loving, this is like hydrophobic. They are insoluble in water. This is what you will write down here, this thing. And then this diagram like this. Can you write down this thing? This is for the
Yes.
4 marks. Okay. And the condition is like same. Compound must have hydrophobic part, that is long alkyl chain, and compound must have hydrophilic part. Hydrophilic means what? Sulfate, CO minus will be there. Different. When it is CO minus, that is soap. SO4 will be there, then it is detergent. Okay. Clear this thing? Then the cleaning action of soap. This is there for 2 marks. Okay. Now we'll understand from the diagram first because this theory you will not understand first. Now look at it. Let's suppose one cloth is there. In that oil droplet is there. So can I say that cloth is not a good condition? That is dirty cloth. Because some oil droplet falls there. Now how it is removed with the help of soap? This droplet. Simple thing. Oil droplet is there. First we will add soap. Soap will contain which part? Soap means what? What will be there?
Hydrophilic and hydrophobic.
Soap will have that soap when dissociate, it will give RC double bond O minus and Na plus will be there. That positive part is not of any use. That carboxylate ion is useful. RC double bond O minus, right? Now in that part, I'm talking about this one. This one is useful. This is what we form first. In this part, one is hydrophobic, one is hydrophilic. Okay. Now look at it. What will happen? Initially, oil droplet was there on the cloth. Now look at it. How this soap, how this that hydrophilic and hydrophobic part, they arrange themselves. Look at here. Who is coming towards the surface of the oil droplets? Hydrophilic part or the hydrophobic part?
Hydrophilic.
Hydrophilic part.
Hydrophilic part is moving toward the surface of oil droplet. And who is moving toward the center of that droplet? Means how
Hydrophobic.
hydrophobic. Like, this is what the arrangement will be there. Now, when I add initially oil droplet was there only alone. Okay, then we have added soap. Then micelle formation takes place. It's like this type of arrangement takes place. Now I will add water. When I am wash with the water, you think what will happen now? When I am adding water, this H2O will be attracted towards this O minus, right? Because this is what polar part. Water is there. So it will attract. So when I am adding water, this entire micelle which is formed here, it will remove from the surface of cloth. Okay, like this. Clear? See here again, entire diagram. Initially only oil droplet was there. Then I added soap. Soap will contain hydrophilic and hydrophobic. How it will be arranged on the oil droplet? That the hydrophilic part will move toward the surface of oil droplet, while the hydrophobic will move toward the center. When I add water, now look at it. This CO minus is attracted toward the water. So when I am adding water, this CO minus all will move, take the entire part and move along with the water molecule, and they give me a clean cloth. Understand this one? That one video is there. I will send PDF. You can just scan. You will get to know that. Okay. Now you read this one. The cleaning action of soap is due to the fact that soap molecules form micelle. This is what micelle formation. When I add soap molecules form micelle around the oil droplet. This is what? Okay. In such a way that hydrophobic part of stereotype means what? This is called as stereotype. Look at it. This is called as stereotype. Sodium stearate. Okay. In such a way that hydrophobic part of stearate ion enters into oil droplet, enters here, while hydrophilic part project out of droplet like bristles, like this one. Understand this one? And when we add water, this CO minus will move toward the water, and means when CO minus is trying to move, it will take the entire oil droplet also. Okay, it's like it has caged this oil droplet. Clear this thing?
Yes, sir.
Now, another classification based on the interaction between disperse phase and dispersion medium. Okay. Now, there is two chances. One thing, disperse phase and dispersion medium. There can be force of attraction between them. One condition. And what is the second condition? There will be no force of attraction. So, when the solution in which disperse phase have the higher affinity toward the dispersion medium, those types of colloids are called as lyophilic colloids or lyophilic sols. Okay, colloidal solutions in which disperse phase has high considerable affinity for the dispersion medium means what? There will be a force of attraction between them. Okay, between disperse phase and dispersion medium. Those are called as lyophilic sols. See, sols is nothing but colloids. Okay, called as lyophilic sols. Solvent loving. Example are what? Gelatin, starch, gum, proteins in water. Then what is the lyophobic? Colloidal solution in which disperse phase has no affinity or the attraction for dispersion medium. Solvent hating, we can say. Understand the basic difference between lyophilic and lyophobic? This is also
Yes,
there
sir.
for 4 marks. Huh? What is lyophilic and lyophobic sol? And explain the difference between them. 4 mark question. 1 mark for definition. 1 mark for definition plus example. 1 mark. 1 mark here, 1 mark here, and 2 marks for the difference. Okay. Lyophilic soul, they are also called as emulsified, while the lyophobic are called as suspensified. Now, first difference, attraction between disperse phase and dispersion medium exists in lyophilic. Such attraction or interaction is absent in lyophobic. Okay. Now, simple thing. If there is attraction between disperse phase and dispersion medium, we can easily prepare lyophilic soul because that dispersion phase is what solvent level. So we can easily prepare, okay, by simply mixing disperse phase and dispersion medium. Such type of preparation, is it possible in lyophobic? No, it is not possible. Why? Because the disperse phase is solvent hating. It doesn't want to get mixed with the dispersion medium. So we require some special method to prepare the lyophobic soil. Okay. Now, as there is force of attraction between the dispersion phase and dispersion medium, lyophilic is more stable. Because already there is attraction between the dispersion phase and dispersion medium. While such type of attraction is not there, forcefully we are trying to form this lyophobic soil, so they are less stable. Clear till this point?
Yes.
Clear?
Yes, sir.
Okay. Now one more thing. Who will get easily dissolved? Means who will have higher affinity to dissolve in the dispersion medium? Lyophilic, right? That's what the point. They are highly solvated or hydrated as particle has greater affinity for solvent. Means what, more and more number of disperse phase particle they want to get dissolved in dispersion medium. Such type of thing is absent here. They are less solvated or hydrated as particles have less affinity for solvent. Clear this thing? This is the fourth
Yes.
difference. Now fifth one. This one is lyophilic, is reversible, while lyophobic is what? Irreversible. Then the viscosity thing, that viscosity in case of lyophilic soil, it is much higher than the solvent. Solvent means what? Dispersion medium. While here viscosity is almost same. Any 4 to 5 difference you have to write down. Okay. The question is only about the stability and reversible case. Okay, but extra also you can write down. Now this charge thing we will study. When we talk about the lyophilic, they do not have charge or very small charge. But in case of lyophilic, they have some charges, either positive charge or negative charge. Okay, so this is the one difference. Okay. And as there is no charge or very charge, so they will not move. Okay. But this will move. This one, the lyophobic one, they migrate towards cathode or anode as they have charges. Okay. This movement is called, that method is there. You have definition also there. Electrophoresis. Now this is one method to prepare the colloidal solution. Now look at it. Listen here first. We have these metal rods. Okay. When we heat this at high temperature, what will happen here? This rod will start melting. Yes or no?
Yes, sir.
Yes, sir.
We have taken dispersion medium here first. Then some ice bath is here. And we are heating this rod. When we are heating this rod, it will start melting. When it will start melting, some small particle will form here in dispersion medium. Yes or no? This rod will start melting and some small particles will form in dispersion medium. Again,
Yes.
as this is molten form will be there, but again the ice bath is there. So that molten form again convert to the solid form. So by this method, what we are trying to do, as this electrode, they are very bigger size, particle size of this metal. But we want particle size in colloidal range. For that purpose, we are heating this rod or this electrode at very high temperature so that they get melted. The molten form, this particle will form here, but ice bath is also there. So again, they convert back to the solid form. Clear this thing? The main process is what? First thing, these metals are there, electrodes are there. Obviously, their particle size is very high. And we are trying to form colloidal solution. For that, we have taken dispersion medium. But we want disperse phase and we want size of disperse phase, that particle between 1 to 1000. Initial electrodes we have taken, their size is already higher. We want small particles. What we'll do? We'll heat this electrode at very high temperature. So they will start melting. When they start melting, they will form small particle. Again, this small particle, as they are in molten form, because of the ice bath, again they convert it to the solid form. So we are doing this thing until and unless we are getting the particle size between 1 nanometer to 1000 nanometer. Clear this thing? This is like one of the method to prepare colloidal solution. That is Bredig-Stark method. Clear?
Yes,
How
sir.
it is prepared, that thing? The
Yes,
same
sir.
thing I written. Okay, same thing I have written here. You can see that animation video also here. Okay. And generally it is used for these metals. Platinum, silver, copper, gold, lead. Now these properties. Now charge on colloids. So what happens here? The charge on the colloids is due to the preferential adsorption of common ion on the surface of colloidal particle. What happens here? Look at it. We have AgNO3 and we have Ki. We know silver has a higher affinity for the halides to form that precipitate thing. So when AgNO3 treated with Ki, which we are taken in excess, what will happen? This iodine will move towards Ag and it will form AgI. What is the another thing will form? Another thing will form KNO3 and Ki will remains, some part will remain there because we are taken in excess. So there will be some remaining here. Now AgI is there which has formed precipitate. So what is the common ion for the AgI here? Iodine from Ki. So this I minus, they will aggregate on the surface of AgI molecule. And this is called as negatively charged colloid. Okay. How this is happening and all that mechanism we'll see later. Okay. Just this is what is meant by negatively charged colloid. Some precipitate will form that let's suppose AgI. That charge is formed because of the preferential adsorption of common ion. Now here I minus is adsorbed, negative charge, negatively charged particle. That's why it is called as negatively charged colloid. Okay. Now AgNO3, in this case Ki we have taken excess. Now look at it. Another case. This time we are taking AgNO3 excess. What will form? Again, the iodine has higher affinity for like Ag, so it will form AgI. Then again, KNO3 will form, AgNO3 is remaining. Now AgI will form. What is the common ion here? Ag. So Ag will get accumulated on the surface here. So Ag will have positive charge. This is called as positively charged colloids. Clear this thing? So colloids will have charge. And generally, which colloids have charge? Lyophilic or lyophobic? Will have
La-
charges. Philic or phobic? Lyophilic colloids have charges or lyophobic?
Phobic, sir.
Lyophobic.
Are we there? Lyophobic will have charges. See, we are written here. One. Particles have charge, either positive or negative. Here emulsion. Are you able to hear me now?
Yes,
sir.
sir.
So what is the emulsion? Disperse phase as well as dispersion medium will be liquid. There are two types of emulsion, oil in water, water in oil. When we're talking about the oil in water, what is the disperse phase? Disperse phase is oil. What is the dispersion medium? Water. Okay, only the classification here. And what is the example? Milk. So milk is the example of oil in water or water in oil. Milk is the example of oil in water emulsion. Okay, paint and all. Now, water in oil. When we are talking about the water in oil, disperse phase is what? Water. What is the dispersion medium? Oil. Okay. Butter, cream, and cod liver oil are the example of water in oil emulsion type. Okay. Now, simple thing. What do you think? Milk is stable or unstable? If we keep milk open for longer duration, what will happen?
It'll get spoiled.
Right? That is what it is unstable. Milk is the example of colloids. Emulsion it is, right? Emulsion is one of the example of colloids. So milk is colloid, which is unstable. So that's what I have written here. In general, emulsions are unstable and sometimes they separate into two layers on standing. Okay. To stabilize them, we add some third material which is called as emulsifying agent. This definition you have for 2 marks. Okay. For the stabilization of emulsion, a third component called emulsifying agent is usually added. Here the definition, what is emulsifying agent? The agent or the component which is used to stabilize the emulsion is called as emulsifying agent. Clear this thing? And what are the general emulsifying agent that you use for oil in water type? Protein, gum, natural and synthetic soap we use. For water in oil type, heavy metal salts or fatty acid we use. Okay. So what you have to remember here, simple thing, what is emulsion? That in emulsion, disperse colloid in which disperse phase and dispersion medium both is liquid. That is called as emulsion. What are the types of emulsion? Oil in water, water in oil. Then you have to classify them like what is the disperse phase in oil in water and what is the dispersion medium. Same you have to say for the water in oil. And one example at least. Milk is the example of oil in water. While what is the example of water in oil? Butter you remember. And then we have some small things like Brownian movement. Now here, what is this Brownian movement? Simple thing. When we are talking about the colloids, which things we have? When we talk about the solution, we have solute plus solvent. When we talk about the colloid, which two things we consider?
Dispersed phase and dispersed medium.
Disperse phase and dispersion medium. When, what is the Brownian movement? Continuous zigzag movement of disperse phase particle in dispersion medium is called as Brownian movement. What is Brownian movement? Continuous zigzag movement of disperse phase particle in dispersion medium is called as Brownian movement. Understand this one? Just definition you have. Clear?
Yes, sir.
Are you understanding this? Okay. Continuous movement. Okay. Now what is peptidization? Peptidization is the process of converting precipitate into colloidal solution. Now look at it. First we'll study this one. Colloids into precipitate. Now look at it. So when I am talking about this one, continuous movement, it is the example of colloids, right? Okay. So here, listen this carefully. This is very important. In colloids, disperse phase particles, they are in continuous movement in dispersion medium. Or they settle down at one position. Which thing is correct? Listen carefully what I am asking. I am asking in colloid, disperse phase particle are in continuous motion or they settle down somewhere at the bottom.
They are in continuous.
If particles are in continuous motion in dispersion medium, then it is the example of colloids. And if particles are settled down at the bottom, then it is called as precipitate. Understand what is the difference? If particles are in continuous movement, which particles I am talking about? The disperse phase particle. If they are in continuous movement, then it is the example of colloids. And if particles settle down to the bottom or aggregates to the bottom, then it is example of precipitate. Clear this thing?
Yes, sir.
Yes, sir.
Okay. Now look at here. What is coagulation? Coagulation, or it is also called as flocculation. See, conversion of colloids into precipitate is called as coagulation process. What is the coagulation process? We convert colloids into precipitate. Now, what is happening in colloids? In colloid, disperse phase particles are in continuous movement. So, when we are doing the process of coagulation, what we are trying to do? We are stopping the movement of this disperse phase particle and we are accumulating them at the bottom. Understand?
Yes, sir.
Okay, that's what the definition. The process of settling down of colloidal particles is called as coagulation or precipitation because we are forming precipitate, right? So coagulation is also called as precipitation or flocculation. Clear this thing? Listen carefully. When we are talking about the colloids, in colloid, disperse phase particle, they are in continuous movement in a dispersion medium. When we stop that movement and when we accumulate all the particles at bottom, that is called as precipitation or precipitate. Clear? So when we convert the colloids into precipitate, that is called as coagulation. Okay. Now, what is meant by peptidization? Peptidization means what? We convert precipitate into colloid. Clear this thing? If we convert precipitate into colloid, that is peptidization. The process of converting precipitate into colloidal solution by shaking it with dispersion medium. Okay. So the process in which precipitate is converted into colloid, that process is called as peptidization. Understand? And to
Yes,
carry out
sir.
this process, we use one electrolyte. That electrolyte is called as peptizing agent. Okay. So the electrolyte which is used to carry out the process of peptidization is called as peptizing agent. Clear? Peptidization process.
Sir,
In
you converted
peptidization,
to collide by shaking it means I didn't understand, sir.
which one?
Sir,
See,
pepper.
when we are okay, yes, yes. Simple thing. Let's suppose we have some water, and I'm saying some precipitate is formed in that water, so it will settle down at the bottom.
Yes,
Yes
sir.
or no? When I'm saying you have precipitate, let's suppose in that case your dispersion medium is water. Some precipitate is formed in that water. When I'm saying some precipitate is formed, obviously some solid part is settled down at the bottom. When we shake with the dispersion medium, what will happen? Those particles of the precipitate which settles down at the bottom, they will be in a continuous movement.
Yes, sir.
Yes or no? Or they will settle down at bottom only. When we shake with the dispersion medium, they will start moving here and there in medium, right?
Yes, sir.
Clear this thing now?
Sir, but one day eventually they settle back down.
So that's what we are using that electrolyte, no? So that they will not settle down.
Oh, that part I didn't understand, sir.
Ah, clear now?
Yes, sir.
Yes. We have this thing in detail, like peptidization and all this, how it is carried out. One thing you understand is what is the peptidization process?
Yes.
We convert precipitate to the colloid. That is peptidization process. For that process, we use one electrolyte, which is called as peptizing agent. Clear? What is coagulation? We convert colloid to the precipitate. That is called as coagulation process. The process of settling down of colloidal particles. Or you can write down this definition also. The process of conversion of colloids into precipitate. Okay. So here we use peptizing agent to carry out the peptidization. Same thing we do it here. We use coagulating agent. Okay. We add one electrolyte so that all particles settle down. That is called as coagulating agent. And there is one rule is there which is called as Hardy. You pronounce this one. I am not able to pronounce this one. This rule. Now, what is that rule says that coagulating power is directly proportional to the magnitude of charge. Simple thing. When most of the time we study about this type of colloids, lyophobic. This one, lyophobic salts. Okay. When in lyophobic, they have charges. Okay. Now I have colloid. These particles are moving. Obviously, this disperse phase particle, as they are in continuous random movement, which is called a Brownian moment, these particles are in movement. They will have some charges over them. Okay. Now I have to settle down them. Means I have to attract them at the bottom. So I will add some other oppositely charged reagent. Okay. If negatively charged colloid is there, I will add some positive charge electrolyte. Okay. And how they accumulate, what is their speed? That depends on what charge is there. More is the charge, more is the speed of that settling down. That is coagulating power, means the process to settle down. That power is more if magnitude of charge is more. Means what? The electrolyte which I am adding, that coagulating agent, if it has more charge, obviously it will help to settle down them easily. That fast process will be there. Okay. So if you have negative colloid or the sol, then the who will have more coagulating power? Obviously Al plus 3 because it has more charge. And we have negative colloids means what? Negatively charged particle. They are in continuous random movement. So if we add something which has more positive charge, then it will help to settle down those particles. Okay, and if you have positive sol, then obviously negative charge, the one having more magnitude, we will add. So what is this rule? What you have to remember? You just ask someone question, what is this rule? What you will write down? According to this rule, coagulating power is directly proportional to the magnitude of charge. And any one example you can write down. Okay.
Sir,
Yes.
sir, I did not understand, sir. We add an electrolyte to keep the
Yes.
particles moving or to settle them?
To settle down, not to moving. We are talking about now coagulating. Coagulation means what? We are converting colloids to the precipitate now. We are trying to settle down them. Colloids to precipitate. Colloids means what? Continuous movement of particle.
Sir, but then from precipitate to colloids also we are adding this
We are
electrolyte.
adding electrolyte, and that electrolyte is called as peptizing agent. It will help particle to in a continuous movement.
Okay, sir.
One is peptizing agent, which helps in the process of peptization. Peptization is what? Conversion of, what is peptization? Conversion of precipitate into colloids. Then we have coagulation, conversion of colloids into precipitate, just reverse case.
Yes, sir.
Okay. This is what rule. Now this coagulating value or flocculation value. What is this thing? Minimum concentration of electrolyte in millimole per liter required to cause precipitation. We are adding coagulating agent, right? How much we have to add? What is that value? That is called as coagulating value or flocculation value. Minimum concentration of electrolyte in millimole per liter required to cause precipitation. Clear this thing? That is called as coagulating value. And there is one simple relation between coagulating value and coagulating power. They are inversely proportional. Smaller the coagulating value means what? Smaller concentration of electrolyte you require. Then it will have higher coagulating power. Okay. This is what the coagulating value or flocculation value thing. It is nothing but concentration of electrolyte that we are adding. That's all. And the last is Tyndall effect. Have you studied about this thing earlier?
Yes, sir.
Do you remember what is that? Can anyone tell what is that? What do you remember?
So the scattering of light by colloid particle.
What? Scattering of light by
Colloid particles.
colloid particle. Okay. Any other? Yes. What is that Tyndall effect? That's what I'm asking. Now, we got two answers. You add both of them. What you said? Like we are able to see the path of light. Why we are able to see the path of light? The answer the first one, because colloids scatters the light. That is called as Tyndall effect. We are able to see here. We have true solution. When we pass the light, we are not able to see the light here. Are you able to see the light here? Path of light. Blue here till here it is stopped. Then we have solution. We are not able to see the light here. But after that we are now you see here colloid. We are able to track the path of light. Look at it. It is moving like this. We are able to see here. Are we able to see here like this? No. In true solution, we are not able to see. But when in case of colloids, we are able to see the path of light. Why we are able to see the path of light? Because colloidal particles, they scatter the light. Because of that, we are able to see the path. Because their range, see, in case of true solution, particle size is very small. So that scattering will not be that much. But here particle size is considerable. So they are scattering the light. And this is called as Tyndall effect. Clear? See your definition. The phenomenon of scattering of light by colloidal particles and making the path of light visible through the dispersion is called as Tyndall effect. Clear this thing?
Yes, sir.
Yes. Okay. So that's what you have for the from this chapter for the IP. Okay. Now one more thing that you have questions regarding the catalysis. Do you know what is homogeneous catalyst, heterogeneous catalyst? Do you remember
When they're in
anything?
the same phase as the
Same phase, yeah.
Right? So those questions you have in that material. Okay, that part I have not taken because we have already studied that part in kinetics. Homogeneous catalyst, heterogeneous catalyst. Okay, clear this thing?
Sir, there's another question where it's asking us to define gold number.
See, that gold number you can directly, that definition is there just. It's like, we forgot that.
Sir, it's 10 ml of a gold sol on adding 1 ml of 10% NaCl.
What?
The mass in milligrams which protects the coagulation of 10 ml
For
of a gold
protect.
sol. Yeah.
It's like for that regarding the coagulating agent is there. I will see that what is that gold number. I don't remember exact definition. That.
Okay, sir.
Yeah. And one more thing will be there regarding the activity of catalyst and all. That also,
Yes, sir.
if
Activity
is
and selectivity.
activity is like how much rate will increase, while the selectivity is like if you have, let's suppose, two reagents are there, A plus B, they will react, and if you use some, let's suppose M catalyst, you will get some C product. Now, in second case, we are using same reactant, but this time you change the catalyst, you will get some another product. That is called as selectivity. Means what? Whatever product will form from the same reactant is depend on the catalyst. That is called as selectivity of catalyst. Clear this thing?
Yes, sir.
Okay.
Are we
Any
going
other
to
doubt?
learn suspensions also, sir?
What?
Are we going to learn suspension also?
Suspension? No, we do not have. We just have colloids.
Okay, sir.
Any doubt here from this part?
Sir, can you give an example for absorption?
So option like fabric dyeing. This one, right?
Yes, sir.
That fabric case, dyeing of fabric.
Okay, sir.
Any other doubt you have?
Sir, can you repeat the example of the stability ones and the particle in the solution?
Which one?
Force attraction.
stability of
So the diagram where there was a molecule and we are talking about force of attraction over there. Sir, in the starting, sir, example of explanation of absorption.
this one. Okay, okay.
The second one,
Here,
can you?
see here.